Okay, so network traffic analysis Neutrino Exploit Kit. And the scenario for this is that the three computers with three Windows computers are active, and at least one of them has an exploit kit, and we must check if any of these hosts were infected. We'll do it by analyzing the pickup file in Wireshark. The pickup file we'll be analyzing is in the file CQURE Wireshark pickups pickup, and the file is called net analysis 01. Okay, after we've opened our Wireshark, we need to determine what were the hosts actually. We need to identify the endpoints. So the first thing we'll do is we'll click on statistics and go to endpoints. And in here we can see in the IPv4, of course, table, we can see what were the IP addresses of the endpoints that were captured in this pickup file. What we also know is that we are interested in one particular network segment, and this is the subnet, which is starting with 192.168.204. So let's check if we got some IPs from that subnet. Oh, there we go. From here to all the way to here, because the 255 is obviously, of course, the broadcast address. Okay, so what we need to do now is to check what were the names of those endpoints, the host names. We can do it by closing this window and go to statistics and resolved addresses. And here in the resolved addresses, let's search for those IPs, 192, and we can only see that we have our one name of a PC, user one PC.local. This is the only PC that name has been resolved from this subnet. It wasn't successful, but what can we do as well is we can apply the display filter. We'll apply a filter IP.address equals 192.168.204.0/24. And let's filter our pickup file. And you can see here when there is an LLMNR protocol, you can see the names of the other PCs. So the PC with the IP ending in 137 is called MyHumps PC. 146 is called Workstation 6, and we should also see the Rocketman PC with the ending 139. Okay, so let's start with analyzing the traffic from the PC that ends with 137. So I will change the display filter from the whole subnet to just the IP address of one endpoint. Let's scroll up. Okay, we are here, and let's search for the HTTPS communication. And we can see that here are the first TCP requests, and it is from our endpoint to the destination 64.168.204. 233.168.102. So what can we do now? We can search for that address in, for example, in the whois search. You can do that as well on your own. So that's 64.233.168, and the ending was 102. We can see that this domain, this IP, actually belongs to Google. So it looks not suspicious from what we can tell. But what can we do as well is that we can copy this IP address, and we can also check the reputation of this address in various places. But here I picked the Barracuda lookup. So let's check the reputation. And we can see that this IP address is not currently listed as poor in the Barracuda reputation system. Okay, so what can we do now? Is that, let's close it. Okay, so right now it seems legit. So we can move forward and add another display filter, so we'll not see the communication to that legit address. So I will add a filter by typing add exclamation mark, which is a negation, IP.address addr equals 64.233.168.102. And let's search. Okay, as well, let's check, let's search for the HTTPS communication here. The packet that is the most interesting for us is that one here, number 2658 with the client hello. We can analyze this the same way we did previously. You can do it on your own, of course, and you should be able to confirm that this IP address is also not suspicious. So let's add as well this IP address to our display filter and exclude it from the search. IP addr equals 64.233.168.105. There we go. Let's search. And right now, let's do the same. And the next packet that is interesting for us is this one, the get request to the IP address 213.186.33 and 19. This is this is a GET request. This is the first time we will analyze the GET request. So let's go here. And here you can see, let me expand it a little bit. You can see the GET request. We can see that the host was theopen.be. Let's also go to the response, and response is in the line 2754 here. So we've got the response 200. Okay. Let's expand this section. And at the end of the section, you can see that the source was was another website call.reganhosting.com. This is interesting. Keep in mind. And now we will go to the packet 2740. So to our GET request, we'll get back a little bit, and we'll right-click on it and click Follow TCP stream. As you can see, we also have the information that the host was the open.be. You can go through the whole TCP stream here, and you can deduct if, in your opinion, it was malicious or suspicious, or it was all right. I can tell you already that it was not suspicious, so we will exclude the whole TCP stream 108 from our search. Let's close this window. There we go. And here you can see that I've already had that prepared. There we go. So we are excluding the whole TCP stream that identifies by the number 108. What we can do as well is that we can filter out this IP address that was associated with the stream, so we'll have less entries. So I will add another exclusion. IP ADDR equals 213 186 33 and 19, not 13. Okay, so now the packet that interests us is a packet number 2793, another get request. We can also follow the TCP stream here. Okay. We can see that the server was the Nginx. We can also find here that the host was call.reganhosting.com, but the referrer was the open.be. So that could suggest that when a user went to the open.be website, he got redirected to the call.reganhosting.com. Okay, so let's identify another packet, which is 2807. It is a HTTP response, and we can see here that there is an iframe with an interesting source on an interesting port. This is not a common port. So let's now go to the previous filter, to this one, and let's include here the destination port, the 22780. So I will add tcp.dist port equals 22780, and let's search. As you can see, we've got two GET requests here and here. we can check them. Let's check if we have anything interesting here. So the GET request is to the flow destination and to the restless destination. We can modify this folder. We can modify this filter again, and let's only look for HTTP. There we go. So we've got a really clear view right now. But what we will need is another packet that is not visible here. So we need to go back one step and search for a packet which is a little bit further, actually. So we need to delete two last parameters. So we need this one, 301.78, which is also a response from the server. Let's take a look at it. We can see the HTML here. And from this HTML, we can see that we've got some sources from Adobe, get Flash Player, get Adobe Flash Player, and also truncated image source, which is encoded in base 64. Okay, so let's analyze another packet, which will be the 3487, this one. But it seems like a normal GET request to Google APIs. With the another packet that is 4332, this one. It looks like a regular download from the Adobe website. So we will go further and we'll look at packet 4461, which is here. Another GET request. And we need to find specific line which we will do by looking at that URL, and we will go to follow TCP stream. Okay. So the interesting part here is that we have a compressed Flash object, which turns out to be the Neutrino Exploit Kit. And in the normal situation, in a normal investigation, what can we do is that we can actually save this file for further analysis. But in this lab, we'll not focus on analyzing malware. This is only the lab focused on network analysis. But I can show you how to do it. You go to File, Export Objects, HTTP, and you look for that packet that you wanted, and let's make it smaller, and you go Save, and you save that file, and you can then analyze it further. So to sum up the whole analysis, we believe that the infection flow began when the user went to the website dopen.be. So that website redirected him to another website, which caused the victim to open the connection to a website with a strange port. And that website with a strange port contained an embedded Flash object, which was malicious. And here we conducted the whole investigation, and we we know what was the root cause of the infection.